Okay, so I think what we had done was we are looking at the data types. We looked at the primitive types earlier, right? And the numeric types. Okay, we also yesterday we looked at UTF-16, right? How UTF-16 works, and then we looked at the array types, reference data. We started with reference data types, and then at the end we are looking at the array types. Right? So, any questions so far? Yeah. Fine. Okay, then we'll proceed, right? Okay. So yesterday, I think what we had done was a two-dimensional array, and we had seen was a two-dimensional array. So normally we look at a two-dimensional array as having a fixed width and fixed, in terms of fixed number of rows and fixed number of columns. Right? So that is not the case in Java. Okay. If you look at it, it's in Java, it's a different one, right? It's an array of an array, right? So the array, first level array is there. It will contain in turn every element is again an array. Okay, fine. And each element which we have at the first level, the array which they have may be of different sizes. Okay, fine. You can have them of different sizes, right? For example, you might fine. We might use something like this. Okay. So yesterday, yes, I think what we had done was in our example here, right? What was done was we created an array like this, two-dimensional array in this manner, right? Okay. Fine. Instead of this, let's see, we may do something different here. We can say, okay, we have a two-dimensional array about maybe sales, okay, and this we are maintaining maybe month-wise, and for each month, day-wise maybe, right, date-wise. So yeah, we understand the first dimension should be 31. Sorry, 12. Okay, we have the 12 months, and then for each month, okay, how many days? Oh, they are different, right? So we may not allocate the second dimension. Okay, and then we'll say, okay, now let's have now we'll do initialization for the second level individually. Okay, fine. So you can say, for example, now I'll say sales of 0 equals new in. Now it's a single dimensional array, right? Each element is again a array. So sales 0 is a array type again. So we'll say, okay, this has 31 elements, right? And then we have sales 1. Maybe this has, if it's a leap year, you might keep 29. Oops, sorry. Okay. Sales of 1, this will be 2. Okay, that's 31. Right? And so on. Okay, so the idea is clear, right? At the end, it will be sales of 11 is equal to new int 31. Okay. So like this, it can be done. Right? So fine. So idea is clear. It's not fixed number of columns for every row. Okay, and row is our month in this case, and each month has different number of days, so we keep a different sized array. Okay, so this is something you should understand, right? So for Java, we say we have the array is not having it's not a fixed two dimension in the sense we understand in C language. Okay, yeah, so that is one difference about C and Java. Other very big difference is like in case of C, it's more like a pointer. Okay, when arrays are like pointers, and therefore it's just referring to a address and then picking up the element based on whatever index you give, or based on that it will calculate the address, and from there it will pick up and give you the value from there, right? So when reading it like this, here in this case, like if someone says we have we have sales of maybe if someone tries sales of 12, what would happen? What would be sales of 12? This would be error. You try to access elements in a array where you do not have so many elements, and then it would be a error. Okay. Fine. Another thing, which I can put for the earlier case, which was like we had. Fine. I'll just go back to what was yesterday. Okay. A equals new int 10 5. Oh, this is how we allocated fixed size. The full both dimensions were specified. Okay. Now in this case, what would be a dot length? That's a question. What should be a dot length? Is it 50? Okay, fine. Let's see what was done yesterday, how it looks like. It looks like this. Okay, tell me what is a dot length. Yeah, fine. Fine, a dot length will be 10. Then you can say, what is a0 dot length? A1 dot length, a2 dot length. Each element will have its own length. Okay, in this case, since we allocated fixed 5 for the second dimension, yeah, initially it will all be 5 for each of them individually. Okay, fine. Fine, clear on this now. Okay. Fine, so that was the other thing. A dot length is equal. Fine, so a dot length is 10. Fine. And then we can have a0 dot length is equal to, fine, and so on. Fine, so we understand this now. Fine. Okay, so yeah. Yeah, so two-dimensional arrays, I think that should now be clear. Okay. Multiple dimensions we can have. I was mentioning yesterday that yes, we can have multiple dimensions. It's not only 2 dimensions, you can go up to 255 dimensions. Will not be required anytime. We hardly go beyond 2 dimensions most of the time. Okay, rarely someone might need third dimension. Okay. Okay. So arrays should be clear now, right? Okay. Yeah. Okay. Now something more about maybe it's related to the use of Unicode in Java. We have seen a Unicode escape being used. Okay. Now coming to rules for identifiers. Oh, what is identifier? Name of file. Okay, if you look at any Java code, I'll put it like this: a Java file. What does a Java file contain? Earlier we had looked at it from the point of view of the kind of things which we can define using a Java file. A Java file is used for defining those 5 kind of things. Fine. A class, interface, enum, annotation, record, right? Okay, that's the only thing which Java can do. fine, Java file. But from the point of view of a lower level, right, what are the things which are there in this? Yeah, we use it to define all this, but what kind of elements exist in that? Okay, from the point of view of a compiler, when it is parsing, yes, what the first thing the compiler will do is identify. It needs input. What is a compiler looking as input? It needs input which is in Unicode. Okay, so first thing it will do is scan the entire file for any kind of a Unicode escape. All other characters, they may be ASCII characters or whatever character set you are following, fine. According to the default character set of your system, it will be able to convert them into Unicode. So for it, the input is Unicode. Wherever a Unicode escape is there, that is to be interpreted as a single character. Unicode escape is \u followed by 4 hexadecimal digits. So wherever first is conversion to Unicode. That's the first part of a compiler. Now it says everything is in Unicode. Okay. For example, we had used what? Instead of class, if you look at that hello world, hello.java, instead of that C, we use \u0063. So first thing it did is, this is U0063, that's C. So it has converted into CLASS. That's the first part. Second phase, then it identifies, oh, there is class, there is hello world, okay, there is int, there's a name here, name. Okay. Fine, so it is identifying, right? So all of this, whatever characters are going here, fine, they are categorized. Let's see how they have been identified. Fine, so we have in Java, what a Java file is made up of. Okay, so a Java file is made up of, okay, a few elements which we see will identify what they are. Okay, so there either, for example, it would be having comments. So first thing it will be able to do is identify comments. Okay, then we have spaces, new line, tabs, fine. So they are known as the white spaces. Fine. So other than this, whatever remains, okay, okay, we say they are some kind of elements, right? What are these elements? Let's see these elements. Okay, the elements will be something which is from the language itself. We call them as keywords. Okay, fine. The name like hello world, main, that's not from the language. Okay, args, right? These are not from the language, but they are from the programmer. Okay, so we call these as identifiers. Right? Then we have operators. We have used plus, right? Or we use that array operator, right? The index operator for array operators. Then, okay, we have separators, operators, separators, keywords, identifiers, and anything else remains. Okay. Only thing here in keywords, from Java 9 onwards, okay, the keywords have been further divided into two categories. Yeah, there's one more kind of yeah, we have identifiers and we have literals. Example of keywords, I think if I put example, that should be okay, right? So example of keyword is, yeah, class, int, yeah? Those are nothing but your keywords. Okay, example of identifiers, hello world, right? Args, main. Fine. Example of literal, yeah. Example of literal, Literals are the constants. Yeah. And someone says, okay, 10, right? Or 0 and 2, or you are writing an octal. And we understand that, right? So, yeah, in hex, right? Those were numeric ones. You could have something like this. Right? Each literal has its own type. Right? If you are put in quote, oh, that's the type char. These two, okay, unless the context is there, they'll be considered of type int. Fine. You put a L, that's of type long. Fine, int long. Fine. You said 12.5, F becomes type float. 12.5 double. Okay. Fine. So we have literals of all types. Oh, we have this also, string literal. Okay. Fine. So literals is next thing we have, and then we have the operators. Yeah, I think so. Yeah, we'll be looking at operators today. So we'll have this minus and so on. Okay, we'll see what they are. And we'll be coming across this. Right? That category is there. Separators, yeah. Comma. Semicolon. Yeah. And like this. Okay. Colon also used some places. So we have so many characters, but they are, there's a use of at the rate character. When we were using at the rate interface for defining a annotation, that at the rate is categorized as a separator. Okay, so everything is identified like this. One more thing which I have to just mention here is, I was mentioning here, is keywords has two categories now. Not early, it didn't have those things. Because one thing Java is giving is a backward compatibility. Okay, when you give backward compatibility, what happens? The rules for identifiers and keywords are almost same. Identifiers are, oh, they cannot be keywords. Other than keywords, anything which falls in that category. Oh, there are certain rules which are followed. Right? So, for that reason, if you have to give backward compatibility, what happens if someone has, can we add more keywords to the language then? In the next version, if I add a new keyword in the language, what will happen? Well, that keyword which I decide to use, someone might have in the previous code, previous version of the, someone might have written a code where he is using that word as a identifier somewhere, because earlier it was valid identifier. Now you are making it invalid because it falls in the keyword category. Okay, so there was a big challenge which was with the the Java development team, that how do we add new features, because for new features we were required to add new keywords. Okay, we are required to add keywords. Oh, I want to, you see that we don't have a keyword like annotation. They reused keywords, they reused interface. So to a large extent, they have tried to reuse the earlier existing keywords to take care of new features. But it's not possible to do it like that. So then they said, okay, we'll have another category of keywords. So let's categorize keywords into two. Okay, because earlier you look at the thing and oh, this token, this element is a keyword or not, right? Now they have something called contextual keyword. In a particular context, they act like a keyword. Otherwise, they are valid as an identifier also. Okay. In a context, in a place where a data type is being defined, maybe it might be valid as a keyword. So there are places where it will be valid as a keyword. Oh, you are using a file called moduleinfo.java. Now, for the module system, which was introduced in Java 9, they would have liked to use something like module itself. Oh, we use a record. Record is not a keyword earlier, right? Because record came in Java 16. So these have been categorized into two, right? Keywords are categorized into two. We have what kind of keywords? Reserved keywords. Okay, so reserved are the original keywords. Okay, reserved keywords are 51. Okay, and we have the contextual keyword. And so these were the ones which have been introduced later. Okay, 51, basically there were only 50. From Java name they have added one more to the unused keywords. Fine. Okay, I'll not list all the 51 now. Okay, let's not list them. But at least I'll tell you which are the unused. They are the reserved keywords, but they are not used. Fine. Yeah. Enum is a reserved key, but it's a used one. Right? Unused. It's not used. It's just there. It has been reserved, but never used. It's not not used in the language, but it is reserved keyword. Okay. What is null? Okay. Const is the unused reserved keyword. Okay. Let me use unused. Yeah. Which are the unused ones? Yeah. I think const unused. Which other? Go to unused. Break. Used, right? Const go to, and then we have one more, I think now. The underscore. Just the underscore. Single underscore is a reserved keyword now. From Java 9, they have reserved it, but they have not yet used it. Okay, it wasn't there earlier, underscore wasn't there, but they introduced this, and they said, okay, we want to reserve this for future use. So at least now onwards, no one will have an identifier which is just a single underscore. That underscore thing, it was introduced in Java 9. Right? From Java 9, yes, it's a underscore, single underscore. Two underscores is fine, but single underscore is nice. Okay, now coming to identifiers, main agenda actually for me was this identifiers. Literals we understand, right? Fine, we'll be able to, yeah, what other literals do we have? Yeah, you were mentioning a few literals when we talked about. Okay, and let me put them here. There are more literals. No. Null is a literal. It's a value, right? It's a value to be assigned to a variable or something, right? Fine. What else? True, false. Boolean is a data type and would be in the reserved keywords. But the Boolean value is true, the true false. So that's in the literals. Okay, and that's in the category of literals. Okay. Okay, now this is what I want to look at. Okay, so rules for identifiers. Yeah, in Java, what is the rule for identifier? Or in C language, yes, what's the rule in C language? Is not allowed. Okay, so anyway, white spaces are taken care, they will never be there. White spaces and comments, right? It's after the white spaces and comments, then the elements which are identified. Okay, so you can have white spaces, you can have comments which will be separating out the various elements. Right? Elements would be separated by any of those kind of things, right? Yeah. For what are the rules for identifiers now? In C language, let's see. Blank space not allowed, and first letter is so spaces. Yes. No. Yeah. The first letter is not a underscore or first letter should not be a number. Number. Yeah. Digit. Digit. Yes. Should not be a digit. But let's first, okay, that first letter, yes, but other than what is it composed of? Let's first see that. And then we'll say, okay, does not start with a digit. That's an additional rule. So first rule, yeah. It can be, yeah, letters. It can have letters, digits, special characters, special characters like the underscore, okay. Instead of special, it's underscore is part of a identifier, yes. And we have, what else? There's one more. The dollar, right? And second rule, right? Okay, so cannot start with a digit. Okay, it cannot start with a digit. What else? Third rule. It cannot be a keyword. That's it. Okay. So Java also follows the same rules, but there's a difference. Char in C is single byte. It uses the ASCII character set. Java follows the Unicode character set. Okay. So we have valid identifiers. When it says currency symbol, yeah, what are the currency symbols we are talking about? In ASCII character set, there is only dollar sign available. Okay, it's only the dollar sign which is available. Whereas here we have more things available, right? That's valid as an identifier. Okay, I'm not sure whether this would work. 9. And 7, 5. Yeah, 6, 6. Oh, it's not showing. The font is not showing me here. Okay. 20B9. It's Shift Control U and you said 20B9. U, because you want to insert by Unicode as Unicode value. Yes, just say this. Okay. Shift Control U and 20B9. Okay. Fine. It works in this editor at least, but you'll have to check with the system, right? On Linux, it works for any of the system you take, like anywhere you can get this. Okay. Fine. So that's one thing. Okay, I'll just switch to the Linux system. Right? Let's see the so that we can. I should be able to show it to you there. Yeah. Okay. And let me use JShell. So we would have said int and then identifier. Okay, variable name is nothing but going to be valid identifier, and so we can say a equals 5. This is why we understand a, right? Now instead of a, let me try. Oops, it's not working. Shift control, it's not taking it here. Okay, Anyway, we understand the Unicode escapes. It will be able to take the Unicode escape int \u, and we can always use the Unicode escape. Right? And I was trying 0966. Okay. 0966 and \u20b9. That's the rupee. Okay. And \u0905 equal to, and that would be an error. Non-ASCII digit. Okay, I think. Okay. I'll show you what was \u0966. No, what was it? And Devanagari 0, the digit 0. Because you can't start with a digit. Fine, I was putting it in the front. It says no, that's not valid for me. Here it's an error to start with a digit. When it says digit, it's not just the Latin digit 0 to 9. Okay, fine. Currency symbol, yes. Any currency symbol is valid. Letters from anything, right? So the earlier one, this is valid. You can see that. Okay, this is valid, and this is invalid. Fine. So instead of defining a class called Hello World, you could have started with a class called Namaste Dunya. Fine. That could be written in. So you can use these identifiers. You can give variable names, method names from our native language. Fine, anytime. Fine. Feel free to use them. You should not be starting with a digit from any language. It's fine. So rule is same. You can understand that. It's just that the character set is a bigger one. It's not just the Latin. It's not just the ASCII character set. Fine. Clear on this? Okay. Yeah. Okay. Okay. Fine. So this was one thing. Fine. So rules for identifiers, that should be clear. And then yes, operators, literals. I think we have seen literals. Okay, operators, separators. Okay, they'll be as we go along, and we'll be seeing all of them. But yeah, those things they are fallen fine. So this is an operator. New is an operator. Okay, we'll be coming across another one today. We'll try to look at it. Is the operator called, but it's also in the category of keyword. Yeah, instance of. These would be kept as keywords, reserved keywords. Okay, new, instance of, but they are basically operators. Right? Okay. Yeah. Contextual keywords. Want me to give some examples. Module. Okay. We have a record. Right? They are contextual keywords. Record could have been an identifier in some other context. Okay. So there will be some places where record would not be allowed as an identifier, right? But because it depends where you are writing that using the word. Okay, the others also, for example, I'll put something called, it's again a contextual keyword. Okay, yield. Fine. Okay, fine. So now let's move to the next topic, right? This is okay. Next. Okay. Okay. From the data types point of view, just for okay, what are the data types we have seen? All the primitive types. Then we have only seen the array types. Okay. What are the other reference data types? In the reference data types, we have seen arrays. What are the other reference types? Classes, right? Yeah. Okay, I had categorized earlier as class type. And in class type, we have the classes, interfaces, not okay, enums, and records. Okay, the interface types, we will have, of course, the interfaces and annotations. Okay, each one can still further be categorized, that's fine. But then broadly, this is what we have. When we created hello.java, we were able to define all the 4 types of things. Okay, so these are all reference types. Okay, one thing is now I'll also put about the subtyping. Types, we have subtype, supertype relationships between the data type, or a type can be a supertype or a subtype of another type. Okay, but there are rules when we look at these 5 of them. They are interrelated. Okay, classes, interfaces, they are interrelated. So as far as classes, class types are concerned, rather, okay, as far as the class types are concerned, they follow a tree structure for supertype subtype relationships, whereas the interface types are not falling in that kind of a category. Okay, fine. Yesterday I had mentioned something about a class called object. Okay, so now here I'll give you a picture about the type system, okay, related to the supertype subtype things. Okay. So as far as the class types are concerned, all the class types, we have something called the object class. There is one class called the object class. Okay. Fine. This is the supertype for all reference types. Okay, it's a supertype for all reference types. Okay, now as far as classes are concerned, if I'm only looking at the class types, okay, you can have a class whenever it is defined will be specifying only one superclass. Okay, for example, we created something called hello world. Okay. Fine. Only one superclass. Oh, hello world is a subtype of object. Okay, you can have a subtype under this, or okay, let me take a better example. You can have maybe someone says, oh, I have a class called vehicle, right? And then we have a subclass of vehicle called car. Okay? But car cannot say I'm a vehicle as well as something else. Right? It's a tree kind of a structure when we look at the class types. Okay. For example, in this tree, we have a few reserved classes. There is a class called enum. It's a name of a class. you define any enum type, it is going to be under this. So one super type for any enum type which you have. Okay, we created hello enum, so that would be under the class called enum. Okay, same way there's another type called the these are names of a class. This and this, they are name of a class. Any record type you define will be under this. Hello record we had created, or that was a subtype of this. So this is the super type subtype relationship which we are having. Okay, but this is related to the class types. Any class type is going to be like this. Okay, but if I introduce the interface types, one of the subtype of objects, what are the lot many of them are all the kinds of arrays which you have, right? All kinds of arrays. Okay, fine. So this is int array, whatever any array you have, int array, byte array, or maybe a string array, fine, array of array, they are all directly under object. Okay, fine. Super type subtype relationships. Okay, what is interface doing here? Okay, what interface is doing is something like this. You have an interface type, it goes and sits on top of any place wherever you like. In this tree structure, interfaces can be fit in any place you like. They can be placed on top of anything. Okay. For example, I'll give the name of some API interface name, so it's not our own one. Fine. So we have an interface like serializable. Okay. Fine. It has a prefix. I'm not showing it currently, but there is one interface like this. And okay, so this interface sits on top of sits on top of the enum type. It sits on top of all the arrays. Yeah, any kind of array, and they would be inheriting. They say, oh, they are all serializable. Unrelated items may have a common super interface. When we look at the class types, it's a relationship where we find, fine, it's always a kind of, right? This is a kind of, okay. Car is a kind of a vehicle, and vehicle is a object. When you create super type subtype relations where we can easily see the specialization, fine. But when we look at interfaces, unrelated items, okay, can be linked together, and we'll say, oh, if I'm talking about serializable thing, it covers so many items, and those items which are serializable, all of them, if you look at them, they may not be related at all. And so interfaces can be used for linking up unrelated items also. Okay, so they are types, and they can create a, so you can create an interface as a type to link up unrelated data types. Unrelated, yes, because they represent a functionality, some kind of functionality which you feel is common for all of them, or some categorization you want to create across this tree structure. Fine, fine, that can be done. Okay, so interfaces, they have their different kind of a usage. Annotations should be taken out from that category, but yes, it's a interface type. Annotation, I think I had shown you the purpose of annotation. It's for defining a modifier. Fine, we define a modifier with the help of annotation. Okay, so not much in the type hierarchy, but otherwise type hierarchy is for classes, it's a tree structure, and interfaces can go and fit anywhere. Same interface. Oh, I want to put it as a super type of this one, on top of this, on top of this, on top of this, anything. Okay. But wherever they are, super type for them is also object. Object is super type for every type.
So with the interfaces, we can introduce additional behaviors.
Yes. Categorization also. When we say behavior, we would be thinking of method. Not only for methods, you may have no methods at all. Right? Create some classification.
Marker interfaces.
Yes. Right? Okay. Okay, fine. Anyway, we'll realize all of this. I just wanted to show you in the beginning. Fine. But as we go along, yes, you can think about super type subtype relationships. Another thing, if you look at the classes, okay, the class types, and the relation with the primitive types, and between the class type and the relation with the primitive data types, right? Let's do that. There are certain unusual things, maybe may not seem very natural, but I'll show the super type subtyping related to this. We know the primitive types. We are knowing about the primitive types. Okay. Which are the primitive types we have? Byte, short, int, long, float, double, char, and the boolean. Okay. And we have the class types for them. We have classes corresponding to these. So we have these classes. There are classes by the name like this: byte, short, yeah, integer, long, okay. So we have these classes corresponding to the primitive types. Okay. These classes are referred to as wrapper classes. And we call them as the wrapper classes. Okay. So yes, related to primitive, there is a class. See, Java doesn't provide, like in C language, we would have a header file where we can keep library. You want to have library for int related thing. So see, int is a data type, right? It's a primitive type. Now for int, there are so many functions to be where I would like to use some utilities related to the int type only. Anything you want to do, I have only an option of using 5 things, not the primitives. Primitives are the ready-made thing. I want to create a library kind of a thing for the primitive type int. Where do I put them? Useful functions related to the primitives. Numeric types, useful functions for them. Where do I put them? Okay, so it's fine. So where do I put them? So I have to have some place, and that's where these classes can be useful. Byte related things, fine, you will find them in the byte class. So each one, for example, as a method. Yeah, I want a method to add. Oh, I have a plus operator, but I still want a method to add also. Add to byte values. Okay, here will be, you'll find such methods. I need a place to keep those methods, and this is the main purpose. Right? They are a placeholder for a lot of methods related to the corresponding primitive types. You want to have some variable for keeping the special values for the float and the double. You know those three special values: positive infinity, negative infinity, and not a number. So if you want them, where do we keep them? And we need a place to keep them. Okay, fine. So float class, for example, I'll show you what we have in float class. So float and double, they both have this. So float dot. So you can't be having in the primitive, right? So we need a place for primitive. So we have, for example, positive infinity, negative infinity, and same way we can have comma something with NaN also.
It is compulsory to have define primitive types.
Primitives are the language defined things. So additionally, as a library, some place where I can keep things related to the primitive. Of course, it has other purpose also, but yes, one of the purposes, a placeholder for lot of functions related to the corresponding primitive type. Okay. From the type system point of view, super type subtype point of view, there are mismatch between these two things. We know the type hierarchy for the primitives. What is the type hierarchy? Double, supermost type. Below that is float. Below that is the long. Then we have int. And below which we have two subtypes, short and char, and short has a byte. Whereas in this case, in the wrapper classes, okay, we don't have that hierarchy. We cannot be assigning a short to a byte or byte to a short. They do not have a super type subtype relation. What has been done is, up to this point, okay, these six things, they have one common super class, and it would be a class here, and those are classes. So they have a common super class called number. Okay, there is a class called number, and we say, oh, these six are number types, and these six are the number types. Then we have the character and the Boolean type. So they fall under number. These are directly under the character object class. Character and Boolean, they are the direct subtype of object. So object has number, number has these six. Okay. Fine. Okay. So just I wanted you to know that we have relation. There is a class for every primitive, and we have a relation like this. There is something called return type void is there. Return type in a method we keep it as void. Fine. It's not a data type as such, but then I just would put one more class name here. Okay, there's a class called void, but don't call it as a wrapper class. And it's not a wrapper class though. Okay, but there's also a class by this name. Okay, this corresponds to the representation of the void, which is a return type.
Can we say it is wrapping void?
No, because void, what is void? Nothing. And this void also is nothing. You don't have object of this type. But we have this class to represent something of this type. The primitive type void also. There are places where it might be useful. Okay.
Like zero.
Uh,
I mean,
no.
in a manner to say that
Okay.
to represent nothing,
Yeah.
we use something called.
Okay. If we define the class called hello world, what does it represent? As a type, what does it represent? Nothing. It's there as a placeholder for a main method. I have a method in it. That's the only thing. Find some placeholder. So these are also placeholders for my functions.
Because we don't have headers in Java.
Yeah.
So
These are like
all
that.
that is kept in that
Yeah.
class. Because if in C++ we put such things in a header.
Header thing. Fine. Okay. So any class can be used as a placeholder for methods. Fine. We'll see. There are. It's not that any kind of method can be there, but when we come to what is a class definition, we'll see what members go in a class definition. That time we'll be able to realize what are the things which we may be putting in such classes. Okay, such classes, what they can contain. It's not any kind of member of a class can you might like to put there. Okay, fine. We'll have to look at it when we start understanding the meaning of a class. Okay, and the various members which go in a class definition. So that will be taken at that time. But this is one thing. Another thing, because that may seem unusual, some of the things, but let me highlight them in the beginning. Uh, about the primitives and the reference. Okay, uh, related to the array types. Now I'm just talking about array. So super type subtype relation, we understand that we have byte as a subtype. Okay, okay, let's say int is a super type of short. Okay, okay. What about int array and short array? Are they related? Are they related with super type subtype relationship? No. If you have a short array, you cannot assign it into an int array. It cannot be used like an int array. This is about the array types for primitives. Whereas, okay, this is fine. So see the differences between the usage of class and a primitive, or reference and a primitive type. Okay. We have yeah, let's say we have a class called vehicle, because this is a good super type of car. Okay. What about vehicle array and car array? And that relation persists. Okay. These are related, right? So vehicle array is a super type for car array. Right? For class reference types, if there is a super type, find two reference types. One is a super type, other is a subtype. Array of the super type is a super type for the array of the subtype for reference types, but not for the primitive types. Right? I'm clear on this. Okay. So if someone says object array, any reference type array, this is the super type. Any reference type array can be assigned to it. So even if I have a, not the int array, but the array of an int array, because this is the reference type. Int is not a reference type. Int array is an object. Arrays are objects, right? Okay. Object super type for all. But when I make object array, right, then that's for array of a reference type, right? This, or someone says string array, that's fine. String is a object, right? Okay, but not the int array, okay, and not just simply the int array, because that's a primitive. Fine. Array relationships, super type subtype relation with primitives, it's not assignable. Fine. One array type is not assignable to the other array type if it's a primitive type. Fine. From primitive to primitive. Okay. Other thing, if you have noted, we can assign long to a int, but not that long to an integer on the other side, right? The class types, no, they are not assignable to each other. But they have a common supertype number. Within number, yes, you can assign any of them to the number type. Okay, fine. Clear? Supertype subtype relation should be clear. And it's all about types. Our Java programming is all going to be about types only. And it's mainly supertype subtype relation. That's what where it matters, because if something is a supertype, whatever we can do with a supertype becomes applicable to the subtype. Right? Whatever valid for supertype, or that same thing is valid for a subtype. Supertype covers the subtypes. Functionality wise, subtype may have additional functionality also. Okay, fine. So done with the types. Okay, fine. Data types. Yeah, you will keep on getting more and more information on all of these things. But and this just, I wanted that you should know this. Okay, that reference and primitives, the way the arrays are different, right? Supertype subtype becomes different. Right? Okay. So there is a mismatch also between the wrapper type and the primitive type in terms of assignment. And you can assign int to a long, right? Int can be put inside a long, but not the integer going into a long.